Okay, I think Rihanna and Ayushi asked this one, I think. So thanks a lot for the question. That's great. Appreciate it. Now, let's look at these charges. Okay. Initially, QB is 0. That has no charge. And initially, QA is a charge negative Q. Then they come into contact. So we have contact charging. So the charge is shared. So after the contact, QB now has a charge of negative Q over 2, and QA has a charge of negative Q over 2. And they are arranged like this. Here is charge QB, see it right here? And then hanging off a string is charge QA right there. So they are separated by a distance r, but we don't know what r is right now. We know this is 12 degrees, and we know the string is 2 meters. All right? I know my string's not the best drawing of a string, but we'll have to deal with it. Okay? So we can use our knowledge of angles to realize that this distance r is 2 meters multiplied by the sine of 12 degrees, and we get that to be 0.42 meters. And we've got our directions x and y all established here. What else do we know? We know the mass of A is 0.10 kilograms. We know that as well. All right, let's draw a free body diagram. And that's what we do. So this object here, A, has a force of gravity on it. There it is. This object A here has a force of electrical repulsion from the charge QB acting on it. There it is. It's all in the x direction. This is all in the positive x direction. This is all in the negative y direction. And we know how to calculate that. K, QA, QB all over r squared. We even know what r is. And we know what each charge is. And we know the electrostatic constant. So that's not an issue here. Next, there's the tension here. But the tension has to be broken down into components, and that's what I've done here. So there's tension Y right here, right? Tension Y. Y is adjacent to the 12 degrees, so tension Y is positive tension cos 12 degrees. Now, we have tension X. Better put a negative sign there. Tension X is in the negative X direction, and since it's opposite to the 12 degrees, it's negative tension sine 12 degrees. There it is. Okay. Better put the vector signs there. Forgot to do that. There's the vector sign. Okay. Now, we have to do Newton's second law in the x direction and in the y direction. And I'm going to drop vector notation here. Notice there's no vector signs. I'm going to put in the direction myself. That's why I've got negative tension x, no vector sign, plus force electric, no vector sign. I know it's in the positive direction, is equal to the mass times acceleration in the y direction. Y component, tension y, right? Tension y is positive, all right? No vector notation. Force of gravity is negative. No vector notation is equal to the mass of the object times acceleration in the y direction. Then I do some substituting. Keep the negative sign. This becomes tension sine 12 degrees. Plug in what the electric force is. I know what that is. Okay. It's not moving. Acceleration is 0. Similar here. Plug in the tension cos 12 degrees. Plug in mg for force of gravity, right? No vector signs. The negative sign that I put in already takes care of that. It's not moving. Acceleration in the y direction, 0. Then I do some rearranging. I bring this over to here, and it becomes positive. So I come up with this equation here in purple. Just brought it over to the other side and made it positive. Similarly here, the green equation, brought this over, becomes positive. So everything is positive on each side of the green equation and the purple equation. I'm going to call the purple equation A and the green equation B, and I'm going to divide the equations. So I'm going to divide these equations. So this side with the k, q, a, q, b over r squared, I'm going to divide it by mg. This is what I get right here. I get that right there, okay? Then the t sine 12 degrees divided by the t cos 12 degrees. Here it is. The t's cancel, all right? So sine over cos becomes tan 12 degrees. And what did I do here? Look what I did here. Oh, I remember what QA is. QA is negative Q over 2. I remember what QB is. Negative Q over 2. So I plugged in what those charges were that we figured out. All right. Then I multiply the negative q times a negative q, and I get a q squared. I multiply the 2 by 2, and I get a 4. So this whole side becomes this. K, q squared, all over 4r squared mg. All right. And I still have the tan 12 degrees here. So now I do some fancy dancy rearranging here, and I get q squared. So this 4r squared mg comes up to multiply the tan 12 degrees. There it is. The k comes downstairs into the denominator, and now I can calculate what the charge is. Because I know r, I know m, I know g, I know k. Plug it in, find a square root. I know you can all plug in numbers, I know you can all square root, and off you go, you find the charge. Okay, thanks for asking the question, and we'll talk to you soon. Bye-bye.